finally done with operators, and I'll see you in the next lecture.
Alright, let's get started with loops. So, first thing first, what are loops and how do they work? Well, loops are basically code that is done again and again until the condition becomes false. So think of it like this. The condition is checked. If it's true, the code or the conditional code is run, and then the condition is checked again. If true, the conditional code is run again, then the condition is checked again. And this cycle keeps on going until the condition becomes false, and then the loop stops. Alright? So loops are very, very useful in Python, and there are two types of loops. For this lecture, we're going to be discussing about for loops, and in the next lecture, we'll actually talk about while loops. And then there's also nested loops and so on, but we'll get to those in a different lecture. So, for loops, okay, what are for loops? For loops basically execute a sequence of statements multiple times and abbreviates the code that manages the loop variable. So a simple for loop here would be, for example, the way you're going to write it is for and then a variable name. You could say for I, for A, for Bob, anything, but normally you use a letter. So for I in range, okay, and then you put the range brackets from, let's say, 0 to 5. 0 to 5. Do what? Print I. Alright, so let's take a quick look at what this code is doing. For I in range 0, 5. All this statement says is assign the value from 0 to 5 to I. So I value becomes 0, I's value becomes 1, I's value becomes 2, and so on until this loop ends. And then all we're doing is print I. So if we run this, we get 0, 1, 2, 3, 4. Fantastic. So this is what we call a very, very simple for loop. Okay? So, what's next with for loops? Well, you can iterate through lists, dictionaries, tuples, and so on. So let's create a quick list over here. I'm going to call it shopping list. And let me go ahead and add some items. So, whoops. Milk, eggs, one sec. Oranges. Alright? This is my shopping list. Now what I can do with for loops is I can iterate through the shopping list. Well, how is this going to work? Let's take a look back up here at what the code was doing. When we said for I in something, all we did is we assigned the value of that something, we iterated through it, and we assigned each of the values to I. So every time a value was assigned to I, the code ran, or the code was run. So over here in our shopping list, what we can do now is for I in shopping list, okay? So for I in shopping list, all we have to do is print I. And when we do that, we're going to get milk, eggs, orange. So it's pretty simple. With the for loop, there's two things you can do. One is you can set a range, and this range can be from any value you want, from 0 to 10, 10 to 15, whatever you want, and it iterates through those numbers. It'll go, if you're doing from 10 to 15, 10, 11, 12, 13, 14. And then what you can do with for loops is you can iterate through a set of data. For example, if I have a tuple, let me go ahead and create a tup. Tup is equal to 2, 4, 3, and 6, 2, 43, 6. I can say for I in tup, print I. And what do I get? 243, 6. So you can use for loops to iterate through data as well. Now let's go back to our range function over here. What we did is we called for I in range, and then we specified the starting value and the ending value. Guess what? There's more to it. Right now, all we've done is we've set the value as the x and the y, so the starting value and the ending value. But there's also one more value you can add to this range function. Think about it. You might get it, you might not. But basically, what it is it is called the incrementator. Okay? You can add the increment factor as well to this for loop. For example, if I wanted all the even numbers, okay, how would that work? I do from, let's say, the first 50 even numbers. So I do for I in range, my starting number, to my nth plus 1 number. So if I want 100, I do 101. And then what am I counting by? I'm counting by 2's. Okay? Again, this is very cool. So it looks like it gives me invalid syntax. That was because I forgot my colon. So for I in range 0, 101, 2, print I. Now, if you're one step ahead of me, what does it print? It prints all the even numbers from 0 to 100. Isn't that cool? So let's go back to the code we wrote. And let me just explain this one more time here. The range function, which is this, takes in 3 parameters. The starting value, the ending value plus 1, and then the incrementator. So do you want to go by 2's? Do you want to go by 1's? Do you want to go by 3's? And you can go negative as well. For example, if you want to count down from 100 to 0, your starting value would be 100, your ending value would be 0, and then you'd say the incrementator as -1. Something along those lines. Well, let's go ahead and give it a try. So can we change this? Yes. 100, 0, -1. Does it allow us? Let's take a look. Yes, it does. As you can see, now we're counting down from 100 to 1. So this is some of the benefits of the for loop. You can do code quickly. Instead of printing out each of the individual items of a list, or let's say printing the numbers from 1 to 5, you do print 1, print 2, print 3, and so on. Instead of doing all those accumulative print statements, you can do it in 2 lines. For I in 1, 6, print I. And all that returns you is... Oh, I'm sorry, I forgot the range function. My bad. Oh, God. For I in range 1, 6, print I, you get 1, 2, 3, 4, 5. So this is where loops come handy. They make your code work much faster, much easier, and much simpler. Fantastic job, guys. If you have any questions about for loops, definitely leave a comment. For loops are amazing to use, and I love them. Now, in the next lecture, what we're going to do is we're going to talk about while loops. So this lecture was a brief introduction to for loops. I just wanted to give you the idea of how it worked. And in the next lecture, let's talk about while loops. Alright, so in this lecture, we're going to be talking about while loops, okay? And let's go ahead and understand what while loops are. So in the last lecture, for loops were something where we used a range function or we iterated through a set of data. While loops, on the other hand, are completely different. The way while loops work is, it repeatedly checks for one single condition. If that condition is true, the code runs. If that condition is false, the code or the while loop ends. Alright? So it's very interesting, very fun. Let's go ahead and check it out. So I'm going to create a variable. I'm going to call it counter. Okay? And I'm going to set it equal to 5. So looks like that slash was on an accident, my bad. And over here, what I want to do is, I'm going to say if while counter is less than 10, okay? While counter is less than 10, print counter, or quota, print counter, and then I want to increase counter by 1. So it's giving me an invalid syntax. That's something I picked up while using Swift, my bad. So counter is equal to counter plus 1. And I'll explain what I'm doing, alright? So 5, 6, 7, 8, 9. Let's go over the code we just wrote. While counter is less than 10, what does this statement say? All it's saying, or I mean pretty much it's simple English, it's all, it will, Alright, so let's take a look at what this code is doing. Over here, the first statement, while counter is less than 10, is the conditional statement. All it's checking to see is, has the value of counter become greater than 10? If it has, then this loop will end, otherwise this loop will go on forever. Now, the next 2 statements, printing out counter and then increasing the counter by 1. Now, you're probably wondering, well, why are we increasing the counter by 1? I mean, why does it have to do with anything? Well, let's go ahead and leave it. While counter is less than 10, print counter, and nothing happens. Well, why? Because right now, if you print out counter, its value is 10. We've already set up counter to be increased to 10. Let's go ahead, set counter back to 5, and print out or run the statement again. What happens? Your system will eventually crash. I'm not going to show you, but in the end, your IDLE will crash. Some bug will happen. Anyways, I'm going to restart my shell. So shell, restart shell. Yes. And that ended the program. Anyways, as you can see, you need to have a way to end this conditional statement. You shouldn't have an infinite loop. Right now, what we created is an infinite loop. Counter's value is never increasing. So this whole condition is sort of pointless, and the function or the code after that will be running forever. Anyways, this was a brief introduction to while loops. Play around with them. Again, they are very interesting. You can play around with the conditions, but the basic format of the while loop is it keeps on checking for a condition, and once that condition becomes false, the whole loop ends. Infinite loops are actually pretty cool. I mean, you can always create one and see how long your machine lasts until it dies, but don't do that. It's gonna be a burden to your machine. Move on, and in the next lecture, let's talk about nested for loops. See you then. Alright, so in this lecture, we're going to be talking about nested loops. And just like we learned about nested if and else statements, the concept is quite similar. Let's get started. So I'm going to create a very simple for loop for I in range 0 to 5, I guess. And then what I'm going to do is I'm going to create another for loop inside of this. For A in range 0 to 5, print A. So I'm going to give you a quick quiz actually. I'm sorry. A quick quiz as to how many times do you think a number will be printed. I'm not asking a specific number, just how many times do you think a number will be printed from this above code? 5, 10, 25, 50, how many? So give it a thought. Think about how this code is going to work. And then once you're done, run the code and let's see. So hopefully you've got your guess by now, and let's go ahead and run this. What happens? Well, it ran 25 times. So if you got 25, fantastic job. Otherwise, let's go ahead and see why. First statement says for I in range 0, 5. Let's take it from the beginning. So 0 was assigned to I. As soon as 0 was assigned to I, this function ran for A in range 0, 5. So in this function, 0 was assigned to A, then it printed A. 1 was assigned to A, then it printed A. 2, 3, 4 were assigned to A, and then it printed A. And then finally, we came back to this for statement. Then 1 becomes assigned to I, and then it goes again. So basically, this function is being repeated 5 times. This is where nested loops come in. Later on, when we get to exercises, when we're creating maybe a prime, finding prime numbers or stuff like that, that's where this comes useful. So actually, you know what? Let's go ahead and create a prime number generator. This is our challenge for today. So what I want you to do is, using your knowledge about for loops and about the modulus sign, the remainder sign. Again, if you forgot what it is, if I do 5 mod 2, it's 1. I believe I have taught you about the modulus. If I haven't, I'm sorry. So modulus sign is basically a remainder sign. So what I can do is I can check, for example, what is 6 remainder 3? Or 6 divided by 3, do I get a remainder? No, because 3 is divisible by 6. If I do 8% 2, I'll get no remainder because it's divisible by 2. But the mod sign gives me the remainder. So knowing that and knowing how your for statements work, can you give me the first 10 prime numbers? This is my challenge to you guys. If you can, fantastic. If you can't, wait for a few seconds and let's try it out. Alright, so with the knowledge of modulus, what I want you to do is create a very simple prime. Give me the first 10 prime numbers. And no, I don't want you to print out 2, 3, 5, 7, and so on. I actually want you to use your code using for loops and get me those first 10 prime numbers. So I'm going to end the video here, and I'm going to give you some time to do it. If you're not sure how to do it, do not worry. I'll explain it in the next video. Otherwise, if you have some idea of how prime numbers work, definitely give it a try, and let's take a look at what you get in the next lecture. Alright, so today we're going to be creating a very simple prime number generator. And in this prime number generator, all we want is the first 10 prime numbers. So I know that the 10th prime number is 29. So I'm going to generate numbers from 2 to 30. All right. So for I in range 2 to 30, my bad, 2 to 30 or 30, yes, 30. What do I want to do? Well, let's think about actually how this prime number generator is going to work. So we have our numbers, okay? The number that we want to check if it is prime is going to be stored in our I variable. Now we want to create another variable, all right? And we want to keep on checking. So let me go ahead and show you via Paintbrush, okay? Paintbrush is a fantastic tool. I'm going to go ahead and open it up and let me show you guys how this is going to work. So explaining is a bit tough for me, especially how this this is gonna work. But one sec, my bad. So okay, all right. So let's take 5 numbers for example. I'm gonna take 10, 11, 12, 13, and 14. How is this gonna work? So these 5 numbers are stored in our I variable, okay? Once our for loop runs, these 5 numbers will eventually come. Now, the way this prime number generator is going to work is, we're going to take another variable. We're going to call it j, okay? J's value is going to start from 2. And it's going to go all the way up till this number or less than this number. So j's condition is going to be, j has to be less than 10 or less than I. This is the condition we're creating over here. J has to be less than I. All right. Now, once this condition is true, we want to check if I percent j is equal to 0. What does this mean? If I percent j is equal to 0, we know that this number is not a prime number. Okay. If I percent 0 or I percent j is not equal to 0, then we increase j by 1. Okay? This whole loop keeps on repeating until j becomes equal to I. And when that happens, we know that I is a prime number. So this may have been a little bit confusing to you. Listen to this again, and once we write the code, you'll actually understand what's happening. So I'm going to go ahead and minimize this or close this, and I'm going to get started on this code. So we have for I in range 2, 30. So I'm going to initialize my j variable over here. J is now going to be equal to 2. So while j is less than I, okay, while j is less than I, what do I want to do? Well, I want to say if I percent j is equal to 0, all right? If I percent j is equal to 0, so what I want to do is, before I actually even add the function over here, if I percent j is equal to 0, I want to create a variable called counter and set that equal to 0. So if I percent j is equal to 0, this means that if the I number is divisible at all, okay, then I want to set counter equal to 1. Else, I want to increase j by 1. So j should be equal to j plus 1. So this cycle will keep on going until j is no longer greater than I, or j is no longer less than I. And then what we can do is say, if counter is equal to 1, right? If counter is equal to 1, then print I plus is a prime number, okay? And then we want to set counter equal to 0, all right? So I think this should work, and don't worry, I'll explain the code, but let's go ahead and run this. Let me take a look here. Looks like it wants an else statement. So else print, whoops, caps lock on. Else print Hi, something random. I'll tell you something later, but right now it's... So it looks like this isn't running. Alright, so I got the code to work, and I'm sorry I didn't show you what I was doing, but I was running into an error, and I fixed it, but your code should look something like this. And let me go ahead and explain what I'm doing. For I in range 2, 30, basically this is going to generate the numbers 2 to 29. Then I'm setting our divisor variable. This is j is equal to 2. So j is a divisor variable, and we're dividing I by j. So we have a counter variable called 0. While j is less than I, we never want our divisor to be equal to our main, what we're dividing. So just like with prime numbers, a prime number is a number which is divisible by itself and 1. If j becomes equal to I, then that fits the value of dividing it or divisible by itself, which we don't want. That's why we've said while j is less than I. Then we're checking if I is divisible by j. Now, if I is divisible by j, we're setting counter as 1. And when we set counter as 1, that means the number is not prime. It's a no-no. We don't want this number to be added to our list of primes. And in any case whatsoever, if it's divisible or if it's not, we want j to increase by 1 since we've already checked if it's divisible or not. Then we're checking over here if counter is equal to 0. So throughout this whole while statement, if the number wasn't divisible by any of the other numbers and it still remains 0, we're printing out string of I. So str is a function in which we can convert integers to strings, is a prime number, else counter is equal to 0. So this if and else statement basically checks if counter is equal to 0, we're printing that this is a prime number, else that means that counter is equal to 1, and we're setting counter back to 0. So if I run this, I get 2, 3, 5, 7, 11, 13, 17, 19, 23, 29 are all prime numbers. Fantastic. So this was a very simple way to generate the first 10 prime numbers. We've used nested loops in this code. We have learned about the string function, which converts integers to strings, and we learned about nested if and else statements, stuff like that, but definitely a fun project. So you can go ahead and expand on this. You can make it go to 100, 200, whatever you want. I will be providing the source code for this, don't worry. So in case your code went wrong or you're doing a mistake, definitely download the source code in the next lecture and have a great day. So what we're going to do next is let's go ahead and discuss, let's take a look. What's next in our... Alright, fantastic. So great job on this project. I have the source code ready. In case you have an error or something, please definitely drop or download the source code and take a look at my code versus your code. If you have a question how things work, again, I agree I didn't explain it too well at the end. I got a little caught up in some error and then I fixed it myself. But if you have any questions on how this works or why that, definitely drop a question. I'll get back to you as soon as I can. And that's it. See you in the next lecture. Alright, so today we're going to be talking about loop control statements. And basically what they do is they deviate the loop from its normal sequence. Once these statements are used, then either the loop ends or something happens, but the whole loop doesn't run like it is, okay? So let's quickly talk about the three main loop control statements. So there's three of them, right? Break, continue, and pass. Break, continue, pass, BCP. So the first statement we're going to be talking about is break. And all break does is it terminates the loop statement and transfers the execution to whatever's next. So for example, I'm going to create a while loop over here. While counter, or actually I'm going to create the counter variable first. So counter is going to be equal to counter is equal to 0. Alright. And then let's go ahead and create the while loop. So while counter is less than 100. Print counter is equal to counter plus 1. So do this and we get all the numbers from 0 to 99. Fantastic. Now, what if I told you I want this loop to end after the fourth number is printed? How would that work? Well, let's go ahead and get our code back from up over here. And this is where the if and else statements come in, or actually the break statement here. So if counter is equal to 4, for example, then I want to break. So as you can see, as soon as we wrote break, it has now been highlighted in orange, which means that it's an inbuilt Python function. And now if we run this, oh, I'm sorry, counter right now is 100 still, so let's go ahead and set counter back to 0. And now if we run this program, we get 0, 1, 2, 3, and then as soon as counter hit the 4, the whole function broke, or the whole loop broke. So this is the nice thing about break. For example, wherever you're running this huge while loop, but somewhere in the middle, once your task is complete, you can break the loop to save yourself some time, some energy, etc. So the break command is actually quite useful, and we'll definitely be using it in the future. Now, the second one I want to talk about is pass. Many a times when you're writing Python code, especially with loops, you'll come to a point where you have this if and else statement, and you need an else, but you're not sure what to write in the else statement. For example, let's go ahead and get this code down over here. So if counter is equal to 4, break, else, else, pass. So all the pass statement does is when you use the pass statement when you don't want any code, anything to be run. So when we use the pass statement in this else part, all it's saying is, I don't want you to do anything. Just continue along whatever you're doing. I don't care about this. Just let it be. So pass is basically what you'd call a filler statement. Doesn't do anything, but it acts as code. So right now, once we run this, we'll get, or let's set the counter back to 0. Sorry about that. Counter is equal to 0. And now if we run this code, so let's go ahead and run it, we'll get 0, 1, 2, 3. Because every time when it checked is the counter equal to 4 and got no, it just got pass. So nothing really happened. So pass is quite useful whenever you're dealing with code that you don't have anything to write, or it's an if and else statement and you're just trying to filler up. Those filler up code, pass is fantastic. Now last but not least, we're talking about the continue statement. So the continue statement rejects all the remaining statements in your loop and moves the control to wherever you want it. So the way this would work is, for example, let's go ahead and create a very simple for loop. All right. So for let's go ahead and iterate through a string. So for I in Python, okay, let's say if letter is equal to h. So actually, if I is equal to h here, equal to h. So I know I haven't talked about this before, but if you iterate through a string of some sort, I will be assigned each character of the string. So Python. So if I is equal to h, then I'm going to say continue. And I'll explain this code, don't worry, but let's go ahead and take a look at what it does. So if I is equal to h, continue. And then I want to print out I. Alright, so a very simple, what would you say? A very simple for loop in which we're using continue. So print I, let's go ahead and run this. We get Python. Wow. So let's see what just happened here. We used this for I in Python, okay? We iterated through each character of Python. And then we said if I is equal to h, continue. And all continue did is it bypassed anything else that was written here, okay? Bypassed it, didn't care about what was there, just moved on, and then the loop started again. So continue is neat when you have code that you don't want to run, but it's there. So you're using that code for the beginning few letters, but then for maybe the 6th letter, you don't need that code to be run. That's where you'd use the continue function so that this all the other code would not be even considered. So let's go ahead and let's do one more example with continue. So I'm going to create another for loop for I in range 0, 5. And then I want to say if I is equal, or if I is less than 2, then I want to continue. And then I want to print out I. So now if you notice, if you run this, we're only going to get 2, 3, and 4. because continue will bypass any statement that is underneath it. And I guess continue is actually quite a neat statement when you're dealing with codes of some sort. But yeah, these are the three main loop control statements. Let's quickly recap what we learned. There's break, there's pass, and there's continue. So what does break do? Break breaks out a loop. If you're in a for loop, it'll break out of it. If you're in a while loop, it'll break out of it. Just completely ends the execution of the code. Next, we have, let's go with pass. Pass is basically that filler statement. For example, if you have code, but you maybe have an if and else statement, and you have the if part done, but for else, you're using like those normal print statements that print out gibberish because you have nothing to do there. That's where you'd put a pass statement so that it would act as a filler code. And then last but not least, we have continue. For example, if you have an instance where you don't want the below code to run, you'd do an if statement for that specific instance and then write continue. And all continue would do is bypass any of the code written underneath it and make sure the loop iterates over once again. So definitely three very neat functions that we'll be using later on in the course. Make sure you mentally note these down or jot these down, that there's break, pass, and continue. And I'll see you in the next lecture. Alright, so before we end this section about for loops, while loops, conditional statements, and so on, I actually want to end this with another part of Python that we haven't discussed, and it's called try and except. So sometimes when you're crawling the web for data, or whenever you're using Python for web purposes, stuff like that, you may run into errors, and you never know when that might happen. For example, you have a program and it's working the day when you have Wi-Fi, the next day it's not working because you don't have Wi-Fi. So instead of getting the error, how do you make it a better experience for the user and maybe show that error message when there's no Wi-Fi or when an error occurs? Right now, what will happen with your code is, for example, if we are trying to open up a web page using Python. So if we don't have Wi-Fi, our build will just crash. However, what we can do is, using the concept called try and except, we can try to access the website's data, and if it doesn't work, go to except and then print out a statement such as you have no internet connection, stuff like that. So the whole purpose of try and except is to make sure that in case any errors occur or in case something goes wrong, then we can go directly to the except and like maybe tell the user, hey, something went wrong. For example, I'm going to say over here, try if name is greater than 3, print hi. As you can see, I haven't initialized the name, so it will immediately go to my except statement. And I'm going to say print out over here, Python ran into an error. Please take a look at your code again. Okay, so as I run this, it now prints out Python ran into an error. Please take a look at your code again. So this is the whole concept of try and except, and this is why I love using it. Whenever in my Python code, if I know what if this variable won't be initialized, what if the user doesn't have internet, stuff like that, always use a try and except. That way, in case your Python build or Python script crashes, then what you can do, directly go to the except and say, print Python ran into an error or something's wrong, please try again, stuff like that. So it's try and except. It's not in many languages, it's especially useful in Python. This is just something I wanted to show you guys. Again, play around with it. Basically, whenever an error occurs in the try portion, it'll go directly to except and follow through over there. So cool, and I'll see you in the next lecture. Alright, so before we head on to some more complex stuff like functions and object-oriented programming, I want to cover some of the basic problems you might be having with Python. The first is commenting. In any programming language that you'll ever deal with, commenting is must. Now, I don't do it, and that's something I should fix, something I should improve on. But whenever, or at least for you beginners, you should definitely start commenting the program that you write or the code that you write. And if you don't know what commenting is basically when you write normal text, right? And that normal text tells you, I was doing this, then this happens, then this happens. For example, let's say you're learning Python right now, And then after this, you pick up Ruby, then you pick up Swift, then you pick up HTML, CSS. And then when you come back to Python, you'll be like, huh, what is this code? I don't understand what I wrote. This is a problem I've had many times when I go from one code to another. This is where commenting comes in. So a comment is basically in Python using a hashtag. So if I use a hashtag, and now if I say something along the lines of this is a comment, it's now taken as a comment. As you see, I have no errors, stuff like that. I can do it like this again, but it gives me an error, invalid syntax. Now, using the shell for comments is not the best thing. Using comments you should use comments in files. So I'm just going to quickly open a new file. And in this new file, you can now see I can put as many comments as I like. So if you're wondering where would I use comments, you would use comments when you're writing your code. For example, if you're creating an if statement, if var or if 3 is greater than 2, print AST. So here I would use the comment that the greater sign signifies or compares the first object to the second object, and if is a conditional statement. So as we go along in the course, make sure to take several comments in your code. Again, most of the programming will be done in the shell, so there's no need to do comments. But if ever you're creating a program in a new file of some sort or in a different IDLE of some sort, then definitely use comments because they're quite helpful. Now, before I end this lecture, what if you have multiple comments? Instead of writing these on 2 lines using several hashtags, adding more and more hashtags, wouldn't there be an easier way if I could open a comment, write as much as I wanted to, and then end the comment? Well, this is where the triple quotation mark comes in. So it's quite neat actually, and all you do is you write 3 quotation marks. And then you can add any comments that you want. It can be any gibberish, any of some sort. However, it can be as many lines as you want. This is the triple quotation mark, okay? You can also use single, triple quotation mark, but it's easier if you just use a double. It's fine. So I can write any comment that I want to, and it can span multiple lines. And then when I want to end it, use the triple quotation marks. Again, one sec. Alright, so I use the triple quotation marks, and now as you can see, this has been created into a fantastic comment. So this is the whole gist of the lecture. I just wanted to introduce you how comments work. Again, quick recap, you use a hashtag symbol for a 1-line comment, and to do multiple line comments, you can use triple quotation marks. See you in the next lecture. Alright, so before we actually get to functions, I'm sorry, you're probably wondering when will we get to them? Well, I want to cover a few more basics of Python. So one of them is quotation marks. Right now, when we create a string and set that equal to a string, I use AST, blah, 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 string is created, right? And if I print it out, I get AST. However, you can also use single quotation marks. I know I haven't talked about this, but let's go ahead and try it out. I can say string is equal to single quotation marks, and then in that, anything I want. Print that out as string, you get AST. And then, let's suppose you put double quotation marks in the beginning and single quotation marks at the end. It gives you a syntax error. So I just wanted to talk about how these quotation marks work in Python. Well, you have to use the exact same quotation mark you're using in the beginning at the end. So if you're starting with a single, you can use a single. If you're starting with a double, you use a double. Now, as we're talking about strings, let's go ahead and cover one more subject with them. And that is that over here, for example, let's say I wanted to create a statement called like this. So, one sec here. It's a nice day today. Or it's a nice day. Okay, a very simple English statement, it's a nice day. However, if we now print out string, it works. It's a nice day. And the reason this has worked is because you're probably wondering, well, we have a single quotation over here. Why didn't it pick up an error? Well, the reason is because the double quotation and the double quotation match. You can put as many single quotation marks you want in the middle, But since it's a string and you've put the double in front and the double in the end, it's okay. However, if we did the same thing, but instead we put a single quotation mark and a single quotation mark, we get invalid syntax. So this is where the concept of escape characters come in. Alright, let's go ahead and bring this line again. To make sure that Python doesn't consider an apostrophe as a string apostrophe and instead as an English wording apostrophe, what you can do is in front of the apostrophe put a backslash. And all this backslash does is it says, hey Python, this is part of the statement. Don't count this as an apostrophe to the string statement. Now if we print out string, doesn't give us an error, it's a nice day. Isn't that cool? So this whole concept is called escape characters. Putting a backslash in front of the apostrophe so that it's counted as normal English text. Fantastic. So this is it to my basics of strings. I just want to talk about a few things. And before I go, or before I actually end this lecture, one last thing. Alright, so let me quickly open up a new IDE, just restarting the screen and stuff. But there's one last thing I want to show you, okay? And this is the concept of, suppose I'm writing a huge if statement. So I'm going to create two variables. I'm going to call mine blue oranges with cheese. I'm going to set that value equal to A. And I'm going to create another variable. Cheese fried dumplings with cherry sauce. Set that value equal to B. So many times in coding, or especially with Python, you'll notice that as you're typing, your screen will take up a lot of the text and it'll go to the next line and stuff. So how do we get rid of that? For example, if I say if blue oranges with cheese is equal to cheese fried... I have no clue what I write. I'm sorry. I have no clue what I wrote. Wait. Let me just copy paste. Command C. Command V. Alright? So this works, right? There's nothing wrong with it. But it's long and it's confusing and I have no clue what's written. So what I can do is using a backslash or wait. I'm sorry. Alright, sorry about that guys. Yes, it is a backslash. I'm not sure why it wasn't letting me do that, but now it is. So I can say something along the lines of if blue oranges is equal to, and then on a new line, I can put in the two equals, and then on a new line, I can say cheese, fried, whatever it is, and then put a colon. That would enable me to put all of this on 3 separate lines. So this is the whole concept of using these multi-line statements, right? Now, these multi-line statements can be used anywhere. For example, if I'm creating, like, for example, let me just bring this down over here, actually. So, one sec. Let me get the error going over here. Invalid syntax. Fantastic. So I want to... One sec. I'm sorry about that, guys. So over here, let's go ahead and get this blue oranges with cheese and this fried dumpling sauce. So I use a backslash and it's getting... Okay, fine. I got you. So I delete all of this. Use the backslash. Use the double equal to signs. Use the backslash. And then I say this cheese fried dumpling with cherry sauce. Command C. Command V. And now what I can do is I can just say print hello, else print hiya. So all I wanted to show you here is how you can use multi-line statements in Python to your advantage. So if your statements are going way off the screen and you don't like that and you want it to be more consolidated, more appealing to the eye, what you can do is you can use these multi-line statements to break up your code into nice, simple pieces like I've done over here. So, fantastic. We have talked about some different, basics of Python, quotations, multi-line statements, and escape characters. Now, in the next lecture, hopefully we'll get to functions. I'm not completely sure what's set for the next lecture, but I'll see you then. Alright, so we're finally here at functions. Let's get started. First thing first, what are functions? Well, let me give you a quick example of how functions would work. Let's say you had, you were writing a Python script, okay? And what I want you to do is, I wanted to print high 5 times. So one way to do this would be for I in range 0, 5, 0, 5, my bad, print high, right? And all this would do is it would print out high 5 times. Now I wanted to print out high 5 times in the beginning of my code, twice in the middle, and once at the bottom. Now this would be a tedious process. I'd have to use these statements multiple times. Is there an easier way to do this? Yes, there is. This is where functions come in. What are functions? Functions are chunks of code that tell Python to do something. They basically reuse the code you have written. For example, I could create a function which has this in it, and then I can call that function wherever I want in my whole script to perform printing high 5 times. So how do you create a function? Well, a function consists of 3 parts. A name, a parameter, and a body. So let me quickly show you how to create a very simple function. Any function you create has to start out with def. And def basically stands for define, or just creating a simple function. After that, you have to type in your function name. As you can see, my function name has been highlighted in blue. That's supposed to happen. So def function name. After that, what you specify is the parameter. So name, parameter, body. Right now we're on the second option, parameter. So the way you can specify parameters is via the normal round brackets, and in here you can write any parameters that you want. For example, let's say, or actually for this purpose, let's not do anything right now, def function name parameters. Alright, once you've specified the parameters you want, and for example if you didn't have any parameters, all you had to do was just leave this empty and then put a colon. So this is the initialization of a function. Now after this, you write the code. So all I'm going to do is I'm going to command C this, my for statement, command C and command V. For I in range 0, 5, print high. That's our simple basic function. So now what I can do is anywhere in my code, if I call function name, I get high. Now is the bracket necessary? Yes, it is. The brackets specify if there are any parameters or not. And it's always good to put the brackets because you have to. So this is a very simple function that you can create in Python. Now let's go ahead and add some parameters. For example, let's say I was creating a very simple calculator. I wanted to take in 2 parameters, first number and second number, and then I wanted to print out the sum of both those numbers. So let's go ahead and do that. Def add num, that's my function name. What are my parameters? First num and second num, okay? And then all I have to do is say return. Now the return key, all it does is it basically prints out whatever you want. So returning a statement just gives it back to you, it prints it out to the console. So I can say return first num plus second num, and I can do this in brackets, I can do whatever I want, but this works. So def add num, first and second are our parameters, and then all we're doing is returning the sum. So hit enter, that works. Let's go ahead and try it out. Excuse me. Add num, and I'm going to try it out with 2 simple numbers, 45 and 3. We know the sum is 48, we get 48. So functions will simplify your life totally. I love functions. I love the whole capability that what you can do is, instead of having to repeatedly use code in your Python scripts in any language you're writing, you can create a function to do that for you. And as you can see, calling a function is a very simple task. All you do is type in the function name and then the parameters. So awesome job, guys. In this lecture, all we did is I gave you a brief introduction to how functions work. Now in the next lecture, we'll talk more about functions and what you can do with them. See you then. So today we're going to be talking about global and local variables. So this is something that all programmers should know, how global variables work, how local variables work, stuff like that. So follow me along. You don't have to type the code that I am, just understand what's happening. Just understand what's happening. So I'm going to create a variable, I'm going to call it total, and I'm going to set this equal to 10, okay? Then what I'm going to do is I'm going to create a new function, def multiply. Okay, takes in two numbers, caps lock, num1, num2, and all I'm going to say here is I want to set total equal to num1 into num2, and then return total. Okay, a very simple multiplication. What would you say? A multiplication function. And what I want to do now is two things. First of all, I'm going to call multiply on two numbers. Let's call it maybe 10 and 23, so 230 exactly. But now if I print out total, I still get 10. So let's quickly go over what just happened. We initialized a global variable total, which is equal to 10. Since it's not in a function, it's not in any other statement, this is a global variable. However, the total we initialized in our multiply function is a local variable. So we cannot call this variable, this total variable, outside of our multiply function. If we call it outside, then it's going to give us an error. Don't believe me? Let's go ahead and give it a try. I'm going to change total to 2else and return total. And if I call the multiply function again, get 230, and if I print out total, I get an error. Name total is not defined. The reason for this is because our initialization of the variable total is, well, it's local. It's only in the multiply function. So this is the whole concept of global and local variables. The local variables exist in functions. They only exist at that level. You can call total as many times as you want in a multiply function, but as soon as you try calling it outside of there, it gives us an error that it's not defined. However, if you define a variable outside of your function, you can call it wherever you want, whenever you want. So this is a simple concept of global and local variables that I just wanted to get down. Now in the next lecture, what we'll talk about is some built-in functions that we can use in Python. See you then. Alright, so this lecture and the following 5 or 6 lectures, I'm going to talk about 1 to 2 inbuilt functions in Python. So before, what I had done is I had done all the functions at once in one single lecture, and I realized that put a lot of information way too fast. So I've divided this down a little bit more so that it slowly sinks in about which functions we're dealing with. So as you know, we've learned that functions ease up our code, they help us a lot, they help us reuse our code, stuff like that. Python also has some inbuilt functions that we can use. So in this lecture, I'm going to talk about the first 1 or 2, and then for the following 4 or 5 lectures, we'll discuss more and more inbuilt functions. So the first 2 I want to talk about today are the abs function and the bool function. So the abs function, or ABS, if you were in 8th grade or 9th grade, you must have learned about the absolute value. Basically does that. It returns the absolute value of a number. So if you don't know what absolute value is, don't worry. I'll give you a quick explanation what absolute value does. So if you have a negative number and if you do the absolute value of it, you'll always get positive. So the absolute value of any negative number or any number will always become positive. For example, if I did the absolute value of minus 10, I'll get 10. If I did the absolute value of minus 63, I'll get 63. However, if I did the absolute value of 2, I'll still get 2. So the way we can call the abs function is basically ABS, and then in 2 brackets, the number you want, minus 43, 43. Absolute value of 2 is 2. Basically, what the only thing absolute value does is, if you want to convert a negative number into a positive number instantaneously without having to maybe add or subtract or do whatever you want, absolute value does that pretty fast. So definitely recommend absolute value. It's a nice function to use. Now the second function we're talking about today is going to be the bool function. So we're going in alphabetical order. A was for ABS, second is bool. Alright, the name bool is short for boolean, like we've talked about, and the bool function, it takes in a single parameter and it either returns true or false based on its value. Okay, so let's go ahead and check it out. For example, if I called bool on the value 0, I'm going to get false. If I called bool on the value 1, I get true. However, if I call bool on anything else, for example 45, I will always get true. I can do bool ASD, I'll always get true. The only time the bool function returns false is when you're using 0, okay? That's something key to remember, something you want to know. Actually, I correct myself, I'm sorry. The bool function returns false when it's 0 or when you're not passing or when you're passing none. So none is basically, it's nil, zilch, nothing. When you do bool none, you'll also get false. So if you're writing some code and if you're trying to check what is the value returning, you can make the user return 0 or 1 if you can use the bool function, check if it's returning false or true, and then make your code run from there. Basically, the bool function is just nice to know if the value is false or true, stuff like that. So let's quickly recap what we've learned. It's ABS and bool. Absolute function converts a negative number into positive, and the bool function returns true on everything except for 0 and none. So you can slowly think about where you could use these functions in your code. I mean, if you have some experience with programming, definitely think, where can I use the bool, where can I use the ABS, stuff like that. Alright, so our next two functions are actually very, related, okay? And the second function greatly will help you when you're using the first function. So let's get started. The first function we're talking about today is called the dir function. Now what the dir function does, and it's short for directory, is it returns information about the value. So far, for example, lists, we've learned that there's the append function, the delete function, stuff like that. But what if you want to know, hey, what are all the functions, all the commands I can use with an array or a list? Well, what you could do is, for example, I can call dir and then the function on a list. So I can put any value in it, and when calling dir, it gives me every single function and command I can use. So I can use a copy, count, extend, index, insert. Don't worry about this double underscore, add, double underscore. All these is not really important to you. The single words are important. So append, clear, copy, count. All these functions you can use with a list. Now, suppose I created a string called tiger, and I set that to I am a tiger. Now I wanted to find out, hey, what functions can I use with the string? Well, the way I can do that, I call the dir function on tiger. So basically what the dir function does is it takes the data type you're using, string, list, dictionary, whatever it is, and then it'll return you the different functions you can use with that specific data type. So dir tiger, I get, wow, all these different functions, upper, format, is title. Now let's say you wanted to find out, well, what does this upper function do? So we've used the dir function, right? We realized that, hey, there's all these XYZ functions to my string tiger, but how do I use them? I mean, how do they work? Does uppercase the first letter of my sentence? Does it uppercase all the letters of my sentence? How do these functions work? Well, this is where the help function comes in. So this is what I think it's very neat, actually, using the dir and the help. So if I want to find out, hey, what does this upper function do? What I can say is call the help function, help, and then in brackets I can say the following, tiger.upper. So I know the function name, I put it dot, so tiger.upper, and I'm calling the help function, and what does it say? Upper method of built-in.string instance returns a copy of s converted to uppercase. Isn't that cool? So what I can do now is I can find out what each function does. For example, this replace function. Hey, that might be pretty cool for what I'm trying to do. Let's go ahead and find out what it does. Tiger.replace. It says return a copy of s with all occurrences of substring old replaced by new. Isn't that cool? So this help function and the dir function are closely related together. So definitely whenever you're trying to find out what functions I can use with this data type, use the help function too. You can find out what do these specific functions do, and then maybe you can use them in your code. Alright, so hopefully you understood what's going on. Again, if you have any questions whatsoever as I continue along through this course, please leave a comment or discussion and I'll get back to you as soon as I can. Other than that, in the next lecture, we'll move on with our inbuilt functions. Alright, so we're going to discuss two quite similar functions, just like last lecture, and both of them are again interrelated. So they both do the same thing, except they differ a bit. So So the first function today is going to be the eval function. Now the eval function, basically, if you haven't guessed already, stands for evaluate. So what you can do with it is evaluate simple Python expressions. For example, if I said eval and then print hello, okay? So I'm evaluating the statement, I get hello. So the parameter of an eval has to be a string. So I could do something like this, eval 23 into 5. So the eval statement can evaluate some simple Python expressions. Again, you can't do multi-line statements with eval. You cannot span multiple lines. However, simple operations, simple print statements, etc. can be done via eval. So they work on simple expressions, and again, I'm not sure where exactly you'd use this in your Python code, but if, for example, if you're getting some input from the user, you tell the user enter a calculation, and then using the eval function, you can return or print out the user the evaluation of that sum or equation the user gave you. So this is the eval function. Again, it's basic. It takes one line and it's simple Python expressions. However, the next function we're going to be talking about is called the exec function. So evaluate and execute. So again, the exec function is quite similar to eval, except you can use it to run more complicated programs. For example, I'm going to create a variable called program, for example, program, and I'm going to set that equal to something along the lines of this. So triple quotation mark. Basically, triple quotation mark means that this is going to span for a few lines. So print hi there, and then print my name is Bob, right? Let's go ahead and end our string or our program. So it gives me syntax error, EOL while scanning string literal. The reason is because I have 3 over here and I have 4 apostrophes over here. That was my bad. Sorry about that, guys. So let me go ahead and make that 3 and run that. There we go. So quickly, let's go ahead and execute this. So if I execute program, now you notice, hi there, my name is Bob. So you can use the exec function to run more complex, more serious code. But for example, if I tried running that using the eval, what happens? It gives me an invalid syntax. So these are the main differences between exec and eval. Both do the same thing. They both run the Python code. However, eval is for simple stuff. For example, simple operations, simple Python expressions. When you get to more complex code, multi-line code, that's where you'd use exec. Alright, so that's it for this lecture, and in the next lecture, we'll continue our inbuilt functions. Alright, so in these following few built-in functions, or at least for this lecture, we're going to be talking about numbers, especially conversion of strings to numbers per se. So in the future, actually, we're going to be talking about a function called input. And all this input function does is, for example, let's say I wanted the user to tell me what your age is. So what I could do is I could say input, enter your age, right? Now this would work, and I'd put in my age is 14, and it would return me 14. Except we want to store the value of input into a variable. So I create a variable called age, and I say input, enter your age. So this would then, I would put in 14, and now if I print out age, it's now 14, which is fantastic. But let's say I now want to use this age for a different purpose. Let's say I want to now see, hey, is this guy eligible for Facebook? So if I say, if age is greater than 13, then print eligible for FB, then I get an error. And it says, unorderable types string greater than int. So Python is actually quite nice when it comes to errors, and it basically tells you what's wrong. Right now it's saying you cannot compare a string to an int. What we have to do is we have to convert our string right now. As you can see, when we printed out age, it came as a string into an integer. So the function we use here is called the int function. So what I can do is, in our age, before running this, convert the age into an integer. So right now our age is a string. It is basically an integer with quotation marks around it. the integer function removes those quotation marks. So now if I run this, eligible for FP. So the int function works on any string which is a number. For example, if I say int 26, I'll get 26. So it basically removes the quotation marks and converts that string number into a regular integer. Now just like the int function works, there's another function called float. Now the float function, what it does is, instead of converting a string into an integer, if you're already ahead of me here, it converts a string into a float. A float is basically a decimal. For example, if I say float 123.456 or 4356, it now gives me 123.4356. So using int and float, we can easily convert strings to integers and decimals. Now what if it's the opposite? I have this fantastic integer, but I need to convert it into a string. Well, if you remember back in our prime number .py file, what we had done is we'd call the string function, and basically all the string function does is it converts a number, an integer, a float into a string. So if I want to convert my age back to a string, all I have to do is say str age, and then I'll get it back as my normal string. So string, int, float, these three functions you can use to convert a data type from string to int to string, string to float, and float to string. Alright, so this is the last lecture in our series of built-in functions in Python. And I just want to cover up a few of the functions we already know to make sure you realize that they are functions, and just a quick recap of what we've covered so far, and then I'll show you one more new function. So the first function in this quick recap of the first 20 or so lectures is the len function. So like we've learned before, is in the len function you can put in any array of some sort, and it'll return you what is the length of that array. Let's try it for a string. If I say len my name, then I'll get 7. So len function is very useful when you want to know, hey, how many characters are in the string, how many objects are in this array, how many items are in this dictionary, and so on. So the len function is quite useful in that case. For example, if I want to create or know how many objects there are in some sort of specific data type, I can use a len function for that. Now after the len function, there is again the max and the min function. So I'm going to again create, or actually in this case, I'm going to create an array, and I'm going to call it, or a list in this case, and I'm going to put in some string values. So A, B, C. So if I call max array on this function or on this array, I get C. So right now, the way this works is lowercase z is the highest value. It's the highest value of the alphabets, and uppercase A is the lowest of all the values in the alphabet. So there's uppercase and lowercase. For example, if I initialize array again with A, B, and C, A and D, now if I say min array, I'll get A. So think of it, capitalized or uppercase letters come first, so A to Z, and then lowercase letters come after that, then A to Z. So lowercase z is the best and uppercase A is the worst. So again, this is a quick example of max and min. We've already discussed how it works with numbers. If you do max array in which in an array which has numbers, it'll return you the maximum number and the minimum number. So there's max and min, there's len. Then after that, you have the range function like we've already talked about. We've seen it in for loops, but you can also talk about that for x or for I in range 0 to 5, 0 to 10, and then you can put the third parameter in range to skip that counter. So last but not least, and this is the last inbuilt function we'll talk about for a good 15 or so lectures, is the sum function. So let's go ahead and let me quickly copy this array, or at least part of this, and I'm gonna say list1, and then set this as this. So 23, 25, 2, 34, 5, 35. Again, it's just random numbers. Basically, I just want to show you the sum function. So if I say sum list1, it returns me the sum of all the numbers in a list. So it's quite useful. Instead of having to iterate through the list and then add it to another variable, you can quickly call the sum of list 1 and get the total sum of everything in your list. So that's it for inbuilt functions. I know you're probably thinking, finally, we're done with inbuilt functions, or built-in functions, however you want to say it. But I just wanted to show you all the different functions you can use with Python. So by now you probably have a clear idea of how functions work. How do you do things in Python? You're slowly understanding what a simple and easy language Python is to use, and it's quite versatile. You can get a lot of things done. So we're almost done with the basics of Python, I guess you could say. So we've learned about, we started off with variables, data types, moved on to loops, if statements, else statements. We learned about the basics, how to comment, pass, break, continue. Now we're finally on to functions. We learned how they work. Now, the last part in this series will be classes, so object-oriented programming. Again, it's also quite simple. There's nothing too complex about it, but I'll give you a quick introduction on how those things work, and then after that, we'll get on to file handling, so opening, closing files, stuff like that. See you then. Right, so we're almost done with the basics of Python. So we've covered everything, almost everything so far, and last topic I want to touch base on is actually object-oriented programming, or classes. So I want to give you a quick introduction on how they work. Alright, we're going to create some very cool and interesting classes, and after 2 or 3 lectures of object-oriented programming, you'll slowly get the hang of how things work with classes. So this is actually the new and updated course. In my previous course, I talked about classes quite little, and I realized that many students had problem understanding how classes work, or how the init function works, stuff like that. So I'm going to read you the definition of class. A user-defined prototype for an object that defines a set of attributes that characterize any object of the class. So basically, a class has a set of attributes that are set for each object of our class. For example, I'm going to create a class, and follow me here, and then I'll explain what's happening. So to create a class, you type in class and then the class name. So class name, and then you can put in whatever you want. I'm just going to put in pass for now. So we've created a very, very simple class. This doesn't do anything. It doesn't have anything in it, but it works. So to create an object of the class, an instance of the class, the way I would do it is by creating the variable name. So this is an instance, and it's part of our class name class. So now instance is an object of this class. So you're probably wondering, why classes? How does it make our life easier? Well, by creating classes, we can easily give attributes, give properties to different objects that are pertaining to the same category. Okay, so for example, if I created a class of Candy, or maybe a class of students, right? Each student will have a name, an age, and a grade. And instead of trying to initialize those variables, call student 1, and then student 1 name, student 1 age, student 1 grade, I can create a class which has all those properties in it. And it makes life a lot more easier, trust me. So let's go ahead and actually do that. Let's go ahead and create a class called students, okay? Class students. Now, in this class students, there is a function called init, right? Def init. So type with me here, def init, and then the parameters. So what parameters does our instance or our students class take? Well, the first one is going to be self. So it always takes itself as the first parameter. The second one is going to be, name, then age, and then grade, right? So these are the 4 parameters that our students class takes, okay? Now the reason we took self is because we need a way to reference this object. There is no way to call this object unless we say self. So what I can do now is self.name will be equal to name, self.age will be equal to age, and self.grade will be equal to grade. So I know this is quite confusing. You probably have no clue what's going on. Stick with me for a good 2 more minutes, and then I'll explain everything that's happening. After this, what we want to do is create an instance of this class. So I'm going to call my student student1. Okay, it's of type students, and his name is Bob. He is 12 years old and he is in 8th grade. I think that makes sense. No, it doesn't. 7th grade. Okay. So student 1, students Bob 12, 7th. So we have now created a class. We have an init function to go with it, and we have initialized an object for our student's class. So now what I can do is I can call student1.name, student1.age, and student1.grade. Okay? So let's explain what just happened. We created a class called students, and we put in an init function. So I have had questions on this, that what does this initialize function do? How does it work? Well, whenever you're initializing an object of your class, you want to give it some properties. For example, here the cars class, okay? You have some fantastic cars, and you're initializing each object of your car's class. For example, Lamborghini. So what properties can you have with Lamborghini? Maybe the engine, maybe the tires, maybe the color. So you add all those properties using this init function. Now all this init function does is it specifically says, hey, which parameters do you want to make it mandatory while initializing your object? So as you can see, when we initialize our student's object, we have to give a name, an age, and a grade. If I try creating my student 2, and if I say students, and I just give his name, let's say Avi, and if I just give him the age, I don't give him any grade, I get an error. Init missing one required positional argument grade. So what Python is telling me is, hey, the class that you have created requires 3 parameters, name, age, and grade. What you've given me is only 2 parameters, the name and the age. I need the 3rd parameter. So this first line just tells us that we want these 3 parameters. After that, what we're doing is we're setting those 3 parameters to our object. So we're saying our object.name should be equal to whatever name we passed in. Our object.age will be equal to whatever age we passed in, and our object.grade will be equal to whatever grade we passed in. So we have to specify that our object's values, or object.name, object.age, and object.grade have to be equal to, or give it some value. So if I did not put these 3 statements, if I go ahead and initialize this class again, and I delete all these 3 statements, and I just say pass, again, that filler word pass, and now if I initialize my student 1, right, and then that works, and if I now call give me my name, I get an error. Student's object has no attribute name. So once you've set the parameters for your class, you have to add the attributes, okay? You have to say self.name should be equal to whatever we've passed in, self.age should be equal to whatever age you passed in, and so on. So once you pass the parameters, you have to add the attributes. Alright, so this was a very basic introduction to classes. We learned how to initialize a class, we learned how to set attributes for a class. Now in the next lecture, what I want to do is I'll show you how to create functions for a class and utilize them and run them. See you then. Alright, so we've learned how classes work, okay? We've understood that you need to put an initialize function if you want to initialize any parameters. We've learned how to call those attributes, and now we're on to adding functions for our class. So I'm going to go ahead and create our students class again, okay? And, or don't need for the brackets there. And then I'm going to create our initialize function, and I'm just going to stick with 2 parameters this time, name and age. And then I want to say self.name should be equal to name, self.age should be equal to age. Alright, so this is our very basic students function. We can initialize objects from here, get their name, get their age. Now, wouldn't life be easier if we could use functions? For example, if I created a function called display student, and when I call display student, I can get their name and their age immediately without having to print out student1.name, student1.age, I can do it in one simple function. So bringing this class down, let's go ahead and add that. So our next function is going to be display student. Okay, now the parameter takes a self because again you need a way to reference it. And over here now what we can do is return, and we're going to return a string. All the string is going to say is student name is, and then go ahead and add self.name, and then or actually in quotation marks over here, and age is, and then go ahead and convert this into a string, self.age. So let's quickly go over what we did. We created a function, display student, took the parameter self, and all we're doing is returning student name is, and then returning the student's name, and then its age is string of self.age. Reason we're using string is because our age is going to be an integer and we have to convert it into a string. That looks good. Let's go ahead and initialize the student. So for simplicity, I'm just going to call my stu. I'm not going to write student1 and all that because that takes a little too long time and I don't like spending so much time. As they say, the best programmers are those who are lazy, and I can definitely tell you I am a very, very lazy person. So stu is equal to students. His name is going to be Chad, and his age is going to be 15. So stu looks fantastic. And now what I can do is I can call stu.display students. So it gives me students object has no attribute display students, and that's because I put that extra s. I'm sorry. It's actually display student. If I hit enter, I get student name is Chad and age is 15. Isn't that cool? So what you can do now is after we've added the attributes to our object, initializing over here, I can use those attributes in different functions. So display student worked fantastic. If I have student 1 to 10 and I want the basic data of what's his name and what's his age, I can say student1.display student, student2.display student, and so on. And all that would do is it would return the name and the age. So again, that's pretty cool. I mean, this was a basic introduction on how we can use functions in our classes, how they work, and how we can call our attributes that we've created to put those values in strings and stuff. So in the next lecture, we're going to be talking about some attributes again, and we'll learn how to add, modify, delete, and set. Okay? Add, modify, delete, and there's one more. I'm not sure it's set, but there's one more function I'm missing here. We'll learn how to do those with attributes. See you then. Alright, so today we're going to be talking about attributes in classes. Mainly 4 functions that will help us understand or getting values of attributes and updating them in our classes. So let's get started. First thing first, what I want to do is create my students class. As you can see, I no longer have it. So class students def init, and then pass in self, name, age. Go ahead and set the attributes. Self.name is equal to name. Oops. Name. Self.age is equal to age. So that's an init function. I'm not going to put any other function after that because I just want to show you some quick simple functions we can use with attributes, and functions don't really have to do with anything there. Now I'm going to initialize student1. I'm going to set that equal to students, and then let's go ahead and give it a name. I'm going to do what's a good name? Fred. Fred's a fantastic name. So Fred, and age, let's do 17. Okay. So this is our student 1, and let's go ahead and make one more. Student 2, just for the fun of it. I mean, you don't really have to, but for the purpose of this lecture, it's fine. So Fred and Mike, and his age is 12. So we have student 1 and student 2, and the 4 functions I want to talk about today is, well, the first function at least is called has attribute or has attr. And all this function does is if it checks to see does this attribute exist or not. For example, if I call the has attribute function on my student 1 and I say, hey, does my student 1 have the attribute age? Then it returns true. I can then check for my, so let's go ahead and check for grade. Does student 1 have a property called grade? So if we do call this function, it gives us false. So you can use this has attribute function to find out what attributes do your students have? And you're probably wondering, well, that's sort of pointless, right? Because we already know, since we have initialized the class with these main parameters, there's nothing else you can initialize it with. However, you're wrong there, because what you can do is you can set specific attributes for specific objects. For example, let's say for Fred example, student 1, Fred, let's say we also had to specify which grade he's in. So how do we do that? Right now, bringing student 1 down here, if I try adding a grade value, it's going to give me an error. It'll say, hey, init takes 3 positional arguments but 4 were given. We don't have any argument for grade. So how do I add an attribute to my first object, grade? Or how do I add grade to my first object? Well, this is where our second function comes in. It's called setAttribute, S-E-T-A-T-T-R. And all the setAttribute does is it'll set an attribute to our class. So I can do is I can say setAttribute student 1, and then I can say age, or for this class, grade, whatever you want to say, grade, and then it takes in the third argument, hey, what do you want to set it? So we're going to set it as 8th. Hopefully this works. Yes, it does. So now if I say has attribute student 1 grade, bring this down over here, whoops, it gives me true. Isn't that cool? So let's quickly recap what we just did. Has attribute checks to see, does this object have a specific attribute? Set attribute, on the other hand, can give or set specific attributes to your students. For example, if you have a list of employees, right? For some of them you're giving vacations, for some of them you're not. So instead of having to add the property vacations to your init function up top, and then for those who don't have vacations putting 0 every single time, for those few that actually have vacations, what you can do is set those attributes by calling this function. So again, setAttribute is quite interesting. When you have specific or special objects that have those extra attributes, you can set them by using this. Now, let's say you wanted to return the value. So just like set and has, there's also a function called get. So all get attribute does, and it's just like what we've talked about before, is I can get any attribute I want by calling this function. So do I want to get the grade of student 1? I'll call get attribute student 1 comma grade. I'll get 8th. If I want to get the age of student 2, then I'll do student 2 and age. So this get attribute, I guess it's the exact same thing as calling student2.age, but I mean, it's just a different function to do it. You can do it both ways, doesn't really matter. Now, the last function I want to talk about is called the delete attribute. So just like there's setting, there's has, there's get, there is delete. So what if we're talking about grades here and you're like, oh, I don't need to add his grade anymore. How do we delete student 1's grade? Well, if you're a step ahead of me, it's going to be delete attribute and then student 1 comma grade. So now if I try saying student 1, or let's call the has attribute now to see if it still has it, we'll get false. So these are the 4 main functions that you use with attributes: set, has, get, delete. All of them are very important, and you can just go ahead and play around with them. Again, we won't be using too much of these functions. I just wanted to show you, hey, these are what you can do with classes, this is what you can do with attributes, and so on. If you have any questions on how these functions work, or how are you setting these values, what is this init, stuff like that, please leave a discussion and I'll get back to you as soon as I can. Now, in the next lecture, we'll again continue our sort of small tutorial with classes, and we'll just talk a little bit more about them. We'll slowly get to inheritance, parent class, child class, stuff like that. See you in the next lecture. Alright, so today we're going to be talking about inheritance, and the whole concept of inheritance, is that you have a child class and you have a parent class, and all the attributes in the parent class, the child class inherits, and then the child class can use them as if they were defined in the child class. So it's not as confusing as I said it to be, but it's actually quite interesting. So I'm going to go ahead and create a parent class, so just call it parent for now. And I'm going to have an initialize function where I don't do anything, just pass in self and just say print class initialized. Okay, and then over here I'm going to create a function, just a simple function. I'm just going to say parent func and pass in self again. And then what I want to do is I want to print out parent func being called. And now I'm going to create a function called, so actually before this, let me create a variable up top. So I'll show you what I'm doing, but stick with me here. So I'm going to create a variable called, let's say, counter for now. And I'm going to set this equal to 10. So in this new function, let's call it def set counter. Okay. In my def set counter, I'm passing in two parameters, self and counter. All I want to do is say parent dot counter should now be equal to, or counter should now be equal to, let me change this actually. So our set counter function, two parameters, self and the new number, whichever the new counter is. So I'm going to call this num, and we want to update our counter variable to become the new num that we've passed in. So def set counter self comma num, our counter variable will now be equal to num. So it might be a little bit confusing what I'm doing, but as soon as we create a child class, I'll show you why I'm doing it. Now, one last thing, let's go ahead and create our print counter, I guess. So def show counter. And all we want to do here is we pass in self and alright, and in here we just want to print out our counter. So I'm just going to say print parent dot counter. Okay, something quite simple, and let's go ahead and convert this into a string. Otherwise it'll give us an error. Okay, so this is our parent class, and now I'm going to create a child class. All this child class is going to have is two very simple statements, def init self, and all this will call is, it's going to say print child class being initialized. And last but not least, for our second function over here, I'm going to create a function called child method, okay, or child func. And all this is going to do is again take in self and just print out child func being called. So we've created two classes, okay, and I'm really sorry that it took so long. I guess I got a bit boring in the middle of that, but we've now finally created two classes, one parent and one child. So as you can see, I made one small mistake, and that is that I haven't made child class a child of parent. So what I can do over here is class child and then in brackets parent. And all that says is, hey, this class is now a child class of our parent class. So we probably shouldn't have named our class child because it becomes confusing when I'm talking about it. But basically by putting our parent class over here, we're saying that this class is now a child of our parent class. So let's go ahead and create an instance of our child class. I'm going to call mine C, I guess. So C is equal to child and child class being initialized. Awesome. Now let's take a look at the functions we can call. So if I say c.childfunc, what happens? Child attribute has no, okay, that's because I spelled it with an H, my bad. So child func being called, there we go. And now the cool thing with child classes is that we can call any function we want of our parent class. So let's go ahead and call the parent func, for example. c.parentfunc. What happens? Parent func being called. So what we can do is, using our child class, we can get any attribute, any function from our parent class and use it in our function. For example, if I call c.counter, I get 10. Because what we're doing is, we're calling any variable, any function that exists in our parent class in our child class. Now let's go ahead and call our setCounter function. So c.setCounter, and it takes in one attribute and it says, hey, what's your new counter you want to set? Let's set it as 20. And now what I can do is, if I say c dot, what was our show counter, I believe? Yes, show counter, I get 20. So what we've done is we have modified the values in our child class or in our parent class via our child class. So we called the setCounter function in our parent class, changed the counter to 20, and then called our showCounter function to print out the new counter. So this is the whole, or a very basic example of child and parent class, where the child class inherits the attributes, it inherits the functions of the parent class, and then what you can do is call these functions, call these variables wherever you want in your child class. So very interesting, I guess. Play around with it. You can go ahead, create multiple child classes, multiple subclasses of a main class. For example, if you want your child class to be a child of parent and parent 2, you can do that by just putting a comma over here. Anyways, I'm not going to go into too much detail about inheritance. This is just a very brief introduction on how things work. Now, in the next lecture, I want to show you one last thing, which is overriding methods. So right now, we've learned that you can call functions, call attributes of your parent class, but what if you have two of the same functions, one in child, one in parent? How do we make it so that the child function does something different? Alright, that's it for this lecture, and I hope to see you in the next lecture. Bye. Alright, so I guess I'll see you in the next lecture. Alright, so hopefully this is going to be the last lecture in our series of object-oriented programming. And by now you should have gotten a pretty good sense of how classes work, how child classes work, how functions and attributes of classes work, stuff like that. So now, lastly, I just want to talk about overriding methods. So I'm going to create, again, a class parent. And over here, I'm not going to put in any initialize function. I just want to call, I'm going to create a function called this is a func, or actually something simple. So I'm going to call this deffunc, and it's going to take in the parameter called self. Okay, and I just want to say print this is a parent function. Okay, very simple class, very simple function. Now I'm going to do the exact same thing with a child class. So instead of typing it all over again, I'm going to go to this line, hit enter, and then I'm going to change this to child, make it a subclass of parent, and then change this to this is a child function. Alright, so now what I'm going to do is I'm going to create a new instance of my child class, and now if I call my func, what do you think will happen? Will it print this is a child function or this is a parent function? Don't hit enter yet, just think about it. I'm going to give you a few seconds. Just think about what will happen if we hit enter right now. Alright, so we're probably wondering, well, why is this printing a child and why not parent? And the reason for this is the whole concept of overriding methods. You can always override your parent class methods. This is something that is set in Python, set in almost all classes, where if I create a same function as in my parent class, I can always override what it does. The whole concept of override means whatever was there will be removed and the new code will be run. So the reason for overriding might be that you want special or different functionality in your subclass, and that's exactly what we have done. Alright, so fantastic job. We have now covered some fantastic topics in Python. We started off with the basics, data types, variables. We then moved on to if and else statements. We learned about commenting, loops, functions, inbuilt function in Python, and we finally ended with object-oriented programming. Awesome job, guys. So if you've had any questions throughout these first 30 or so lectures where you've been wondering, hey, what's this, what's that, how do classes work, why object-oriented programming, please don't hesitate to leave a discussion, leave a comment in the forums, and I'll get back to you pretty soon, hopefully, and I hope to see you in the next lecture. Alright, so this whole section is going to be about files, so manipulating files, adding data to files, reading off files, and so on. So I just want to touch base on the subject, and again, it won't take too long, hopefully max 5 or 6 lectures, and we'll just cover how you can use Python to manipulate such files. So the first thing we need to do before we even talk about all this Python stuff with files is we have to create a file. So most of you should know how to create a file, and if you do, just skip ahead, go ahead and create a very simple text file, and make sure you know what the file name is, and then you can just go ahead and see the next lecture. Otherwise, just stick with me and we'll create a very simple file. So if you're on a Mac, you need to open TextEdit. As you can see, I have TextEdit opened up right now. So what you can do is you can hit Command Tab on your keyboard and search for TextEdit, and then all you have to do is open it up, and it will open it up like this. Now if you're in a Windows machine, what you have to do is, well, on the left hand side of your screen, if you're using Windows 7, you're going to click the Windows icon and search for Notepad. Or if you're on Windows 8, you're going to say Command S, okay? Or it's not Command, I'm sorry. Windows key plus S, and what that will do is it'll open up the search bar on the right hand side. And that's where you can search for Notepad or whatever text editor you're using. And once you open it up, the procedure for creating the file will actually be quite similar. So I again am on my TextEdit, and over here, this is looking fantastic. So just go ahead and enter a few lines of text, anything you want. So this is a Python file. Okay. What else can you say? Python is a fantastic language. Fantastic language. And let's do one more sentence. Let's say anything you want. So Mac OS is a fantastic OS. Maybe if you're a Windows fan, you can do Windows. However, these are 3 lines that we've written in our file. I'm going to go ahead and save this. So Command S, if you're on a Windows, then it's File, Save As, or Control S. And it's going to ask me, hey, what do I want to save it as? So Windows people should be doing the exact same thing as I am. Save as, and then I'm going to save it as test file. And I'm saving it in my documents. And instead of file format, instead of rich text document, I want to save it as .txt. So right now, as you can see, I don't have the option as .txt. So the way we can change it into .txt is make plain text. Okay. So if you're on a Mac right now, please make sure you do this. Go to Format, Make Plain Text, and now we can save this as a text file. So as you can see, it's now Unicode UTF-8 test file, and I'm saving it in my documents. For Windows, again, you'll do Control S, File, Save As, and then go ahead, give it a name of test file, and make sure the extension is .txt, and then save it. Fantastic. So now you've created your text file, and in the next lecture, we'll go ahead and learn about reading off files. Alright, so we've now created our text file, and now for this lecture, we're going to learn how to read off that text file. So we're going to be covering quite a few functions actually that you can use with files today. The first function is going to be the open function. So whenever you're creating a file, or at least getting it into Python, the way it works is you type in a variable name for that file. For example, I can call this file1. Then you put an equal sign, and then use the open function to get that file opened. Excuse me. Now, the open function takes in 2 parameters. The first parameter is the file name. So we called our file testfile.txt, and then we have to put in an access method. So the second parameter of the open function basically says, hey, how do you want to open this file? Do you want to read off it? Do you want to write off it? Do you want to do both? Do you want to append off it? Etc., etc. So there's, I believe, 15 or 16 access methods. I'm not sure the total number, but we won't cover them all. We'll cover the main ones. So for the purpose of this lecture, since we are just reading off the file, go ahead and put an R. And all this R signifies is that, hey, we're not going to append to this file. We're not going to read off this file. All we're going to do, we're not going to append. We're not going to write. All we're going to do is read. So if this gave you an error, for example, you hit file1 is equal to open testfile.txt, R. If this gave you an error, message me in the forums and I'll tell you how. I don't want to deviate from the course right now since, well, it would be confusing to a lot of people. However, if you did get an error for this small piece of code, definitely put a question in the forums and I'll get back to you almost instantaneously. Again, it's a quick fix, but I don't want to deviate too much from what I'm trying to get to right now. Alright, cool. So this worked for you, fantastic. Now what I want to do is, well, I want to first of all read off this file. So we've opened the file, file1 looks fantastic. How do we read off this file? Well, it's file1.read. Very simple. So look at that. This is a Python file. Python is a fantastic language. Mac OS is a fantastic OS. I missed an A over there. I'm sorry about that, but that's fine. So this is pretty cool, right? We read off the file, we got our text. Now, just for fun, I want you to read off this file again. What happens? You only got a quotation mark. Well, this is where things get interesting. Think about why this happened. Why did we get a quotation mark? Well, the best way to explain this to you would be in terms of a cursor. Think about when you're reading a file, your cursor starts at the beginning. As you go through each word, your cursor moves slowly across each word, right? For example, if this was a file, this simple line was a file, I started from the beginning, I slowly read through the whole file. At the end, when I read off everything I needed from my file, my cursor is now at the end of the file. Now when I try reading the file again, hey, where's my cursor? It's at the end of the file. There's nothing else to read. So this is where a slight problem can encounter. You may think, hey, why isn't it reading? Well, the real issue here is our cursor currently is at the end of the file. What we have to do is get this cursor to the beginning of the file. So if you're wondering, well, I don't believe you, how is that true? What I want you to do is go ahead and type in this function, file1.tell. Tell. So all this tell function does is, it asks Python, hey Python, tell me where am I in this file? Well, Python told us that you're at the 84th character. Now, I'm not going to count all these characters, but I can definitely tell you that the 84th character is either the N or the character after N. So right now, our cursor is at the end of the file, and our goal is to bring it back to the front so that we can read it. The way to do that is, well, create a variable called position. Position is equal to file.seek 0, 0. Alright, looks like I forgot our file name was file1 and not file. So position is equal to file1.seek, okay? Now, I'm not even sure you had to assign it to a variable. Let's go ahead and try it out like this. Or actually, so file1.read, if you call this function again, you're now going to get the whole file. All I want to do here is I want to set this back to the beginning, just saying this, 0, 0. So we get 0, and now if we say file1.read, yay, cool. So I was mistaken. You didn't have to set file1.seek's value to a position. I'm sorry if I went a little bit off track over there. That was just me testing a few things out. So let's quickly recap what just happened. Right now we had position is equal to file1.seek. You know what? Just forget this. You don't have to assign this to a variable. All you have to do is say file1.seek 0, 0. And all this means is I want you to move the cursor back to the beginning of the file. Okay? And once that's done, we can now read it again. If we say file1.read, this is a Python file, blah, 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 blah. So as you can see now, we can now read the file. So I'm setting this back to the beginning. And there's one last thing I want to show you, and this is that, let's say I just wanted, this is a Python file. I didn't care about what's after it. I only wanted the first 20 or so characters. Well, let's go ahead and try it out. So what you can do here is you can say file1.read and then in brackets the number of characters you want. So I know that this is a Python file is 21 characters. So if I hit enter, I get this is a Python file. But now, let's say I call this function again, file1.read 21. What do you think happens? Well, it starts from the period. So this is very interesting. Wherever you let go from your cursor, if you read the first 10 characters, the next time you read anything, it'll start after the 10th character. That's something key. You must realize that whenever you're reading off files, remember where your cursor is so that you're not getting any gibberish or random text. Awesome. So let's do a quick recap of what we covered. In the beginning, we learned about the open function. We realized that you need to put in the file name and you have to put in an access mode. After that, the file1.read function gives us the entire text in our file. Now, what we realized is the cursor starts at the beginning and goes to the end. And then the cursor remains at the end, causing the next time we call file1.read to give us a quotation mark. We realized that again, or actually verified that by calling the function tel, which told us where our cursor is in the file. We got 84. So to reset the cursor back to the beginning, we called the function file1.seek 0, 0. And all this did is it reset our it reset our cursor back to the beginning. Then we can read, we read the file again, we got the data, we set it back to 0, and then I also told you, hey, if you want the first 10, the first 21 characters, you can specify the number of characters in your read function. So by doing that, we got this is a Python file and nothing else. And then I also told you that once you read those first 21 characters, the cursor is now at the 22nd character, or yes, the 22nd character. So it'll start from there the next time you call the read function. Also, so this lecture we covered everything there is to reading off files. Now in the next lecture, let's learn how to write to files. See you then. Right, so last lecture we covered about reading. We learned how to read off files, and now what I want to talk about is writing to files. So again, it's going to be quite similar. Just like there was a read function, we're going to use the write function, but the access mode will be a little bit different. So, excuse me, let's go ahead and open up this file. I'm going to call my name file or F, it doesn't really matter, and go ahead and use the open function. Put in our file name, testfile.txt, and then it's going to ask us, hey, how do you want to open it? So this is where we can now decide how do you want to open it. So W, if you put the access mode as W, it only opens the file for writing, and that's something that we can definitely do. So let's go ahead and put in W. So test file W, and that works. So now let's go ahead and just do read and see what happens. So it gives me the operation not readable, and that's because we have just now used W, and W will not allow us to read off the file. That makes sense, I guess. So now using the write function, I'm going to go ahead and enter some text. I have entered some text into this file. Let's see if this works. Okay, 65, fantastic. Now, to see if our file has actually written, okay, what we can do is close the file. So f.close will close the file, and then we can reopen it using our, using our R access mode. So test file and R. Oh, I'm sorry, I forgot the .txt. My bad. So test file.txt and R. There we go. And now if I say f.read, I've entered some text in this file. Let's see if this works. Awesome. So let's quickly recap what just happened. We opened our file using the W access mode, and then we wrote to the file using the f.write command. Now it wrote to the file and then it returned how many characters long this sentence was, or where the position is now in the file. Then we closed the file and reopened it using the R access mode, enabling us to read off the file. Now there are different modes which can do both. For example, WB plus opens a file for both writing and reading. So instead of using W, you could have done WB plus, but you can play around with it. Definitely search online for all the different access modes. There are tons and tons, trust me when I say that. So this is it for writing. Again, it was a short lecture, just wanted to show you how to write to files, and then in the next lecture I'll show you how to append. So one key thing here, actually, before I end the lecture, writing will rewrite the file, okay? Whenever you use the W access mode, if the file already exists, the file will be rewritten. So as you remember, we had those random lines of code, Mac OS is a fantastic OS, stuff like that. Those lines were rewritten, and now what exists in that file is just this. So W is not good if you want to continuously append to a file and add more and more text. If you want to completely rewrite the file, you use W. If you want to append, if you want to add more to the file, you're going to use A. And we'll talk about A in the next lecture. Alright, so today we're going to be talking about appending to a file. So we've talked about reading, we've talked about writing, and we're almost done with this whole file concept. So appending to a file basically all it does is, suppose we have XYZ already written into the file. Appending to a file won't delete that XYZ. Instead, we'll be able to add more to that XYZ. We can make it XYZ ABC. So let's go ahead and open up our text file again. I'm going to call my file again F. And F is going to be equal to open testfile.txt, comma, A. And all A will enable me to do is it will allow me to append to this file instead of rewriting. So now if I say f.write, and then I want to add to my file on a new line, this is my appending text to my test file, okay? So I now do f.write, and now I believe that my file has been appended with this new data. So to check, what I can do is I can now close my file. F.close will completely end anything that's going on with this file. And I'll reinitialize my file with my R. So F is equal to open testfile.txt R. And then F.read. I've entered some text into this file. Let's see if this works. This is my appending text to my test file. Awesome. So as you can see, the appendation has now worked. To append, all you have to do is set the access method to an A instead of an R or a W. Now again, there's features like A+, one sec, let me take a look at my reference over here. There's A+, AB+, AB, stuff like that. Definitely take a look. Again, I'll tell you a few actually over here. So A+ opens a file for both appending and reading. So what we could have done here is, let's bring this back down, or actually, let's go ahead and close this and then open this up again. But instead of A doing A+, let's see what happens. So I'm going to go ahead and write again some more text. This is some gibberish. Okay. And then if I say f.read. Alright, so that's because my cursor right now is at the end. So let's do ahead and say f.seek 0,0. And then f.read. Ta-da! So as you can see, using different access methods, we can specify or make our life a lot more easier. Using A+ enabled us to append and read both at the same time. A just allowed us to append. The same way, if you want to write and read both at the same time, I believe we can use WB+ or WB. So these are the different access methods you can use, and again, we're almost done with this whole file section. Now, last but not least, let's go ahead and learn about copying one file to another file. Okay? See you in the next lecture. Alright, so today we're going to learn how to copy files, and this is not some function Python has created. This is actually going to be a program that we're going to create in which we take in a user's file name, for example, and then all we do is we open it up, get the data from their file name, and then write it on to a new file. So the concept is actually quite cool, and let's get started. the first thing we need is the user's file name. So I'm going to call this UFN or UFN, user's file name. And that's going to be equal to an input. And all we're going to say is, bro, enter your file name. Okay? So once we do that, hit enter. So what's our file name? Well, for this purpose, let's go ahead and use test file. So now that we've done this, UFN is now equal to test file. So what we have to do now is create file1, set this equal to open UFN, read, or actually R. What does it do? It gives an error. No such file or directory, test file found. So as you can see, this is our first error we've run into. We have to add that .txt to our UFN. So what we can say is UFN is now equal to UFN plus .txt. Okay. Now let's go ahead and run this file again. File1 is equal to open UFN, R. There we go. Now let's go ahead and create file2. File2 is going to be the new file which will hold all the data of file1. So file1 is equal to open. Now we haven't created any file. So if you remember that I've talked about, if you don't have a file that's been created, Python will create one for you using the name given. So I'm going to call this copied file.txt, w. Okay? So now what I have to do is, well, think about the codes that are going to come next. We want to read off file1 and set all the data of file1 to file2. I'm going to pause this video here and give you a few seconds to try it out. Alright, hopefully you managed it. If you didn't, don't worry. So the code you want to write here is file2.write should be file1.read. Okay? So basically all we're saying is all the data in file1 should be written to file2. Okay? So as you can see, all the data in file1 has been written to file2. Now I'm going to go ahead and say close file1, file2.close because we don't need them anymore. And now I'm going to reopen our file2, except instead of W, I'm now going to say R. So file2 is equal to open, copied file.txt, R. And now if we go ahead and read off this file, well, if you're a step ahead of me, ta-da! We have now gotten all the text from the file name the user entered into a completely new file. So in this lecture, we learned how to copy files from, if a user gives you text, if a user gives you a string which contains the file name, what we did is we got all the data from that file name and then recreated a new file and set the data to that file. So again, a very cool program. If you want to save this and keep this for future references, what you can do is go ahead and say file, new file, and then in this new file, type in the whole code and save it. Again, I'm not going to do that right now. Probably in the future when we get to more complex programming, I'll start using the file. But for now, fantastic job. Again, if you've had any questions throughout this whole file IO, how does a read work, write work, what does a seek mean, tell mean, stuff like that, any doubts whatsoever, definitely leave a comment or question and I'll get back to you as soon as I can. Now, in the next lecture or in the next section, we're going to cover some modules in Python. So we learned about OS this section, and in the next section, we'll cover quite a few different modules such as the random module, OS module, and so on that will greatly benefit us in the future whenever we're doing Python programming. See you then. Alright, so in the last section we talked about files, right? Reading files, creating a file, how to write to files, append, etc. And we basically got a very good understanding of how files work. Now this whole section is going to be about modules. Now we discussed modules quite briefly in our file section when we were talking about the OS module. But this whole section will now talk about many different modules that are in Python right now. So again, what are modules? Well, modules are libraries that hold functions. And what we can do is we can call those functions in our program. It's much easier to import modules and use their functions rather than creating our own functions, which will take up a lot of time, a lot of space, and a lot of code. So modules, right? The first module I want to discuss is the random module. So again, just like last time, you have to always use the import statement to get that module inside of your program. Now import random imports the random module. Now what do we want? Well, let's talk about the different functions there are in the random module. Alright, so the first function I want to talk about is the randint function. Okay, so in every programming language that I've dealt with so far, at least the main ones, they always have some sort of random module in which you can generate a random number. For example, in Swift, it's arg4random. In Python, it's randint. So the way this works is, for example, what I can do is I can say print, and then in the print I say random.randint. And all this says is, hey, I want to generate a random number between x and y. So right now it says you haven't specified anything. So let's go ahead and add the range. Where do we want a random number from? So let's do 0 to 100, okay? And we get 79. Let's go ahead and do this again. What do we get? 91, again 87, and it goes on. So what does this random.randint function do? It generates a random number, any random number between your initial value and your end value. So this was a very basic lecture on how the random.randint function works. And in the next lecture, using this knowledge and using our knowledge with if-else statements, we're going to create a very simple guessing game. See you then. Alright, so in the last lecture we talked about the randint. We realized that if we call the function random.randint and putting the initial and final value, we can generate a random number. So that's pretty cool, right? Now, the next thing we're going to talk about is a very simple guessing game. And to do this, I'm going to create a file, okay? Or file and, no, sorry, one sec. I have to select ideally first, file, new file. And I'm going to be doing the majority of my coding in this file. And the reason for that is, well, it's a little bit difficult to write big program statements inside of the IDLE because if you make a mistake and hit enter, it gives you an error, then you have to, go back to that line, hit enter, get that code back, and then reformat it. So instead of doing all of that, all I want to do is put all my code into this file, okay? So we're thinking of a guessing game, right? And how is this guessing game supposed to work? Well, what I think is that the computer will guess a number, and we then are gonna, enter a number. If that number is lower than the computer's guess number, the computer prints out guess higher. And if the number is higher than the guess number, then the computer prints out guess lower. And if it's equal to the guess number, then the computer prints out you're correct. So again, a very simple guessing game. And think of it as a small challenge. I mean, we've learned about the random module, we've learned about the if-else statements. So using this knowledge, I'm going to pause this video here and I'm going to give you a few minutes to try and figure out if you can create this program. So here I go, I pause the video. Alright, so if you did create your guessing game, that's fantastic. I mean, I'm definitely proud of you. If you haven't and if you're still wondering how to do it, don't worry, I'm there for you. So the first thing we want to do is let's talk about what's needed. So we're using the random .randint statement, right? So to do that, we need to import our random module. That's the first thing. Now the second thing is we need a variable to hold the computer's guess initially. So I'm going to create a variable called compGuess or comGuess. I'm going to set that equal to random.randint, and then let's say we're guessing between 0 to 100. Okay, there we go. So the computer has now guessed the number. What instructions should be given to the user? I'm going to say user guess is equal to one sec, let me think about this. So user guess is equal to input enter guess a number between 0 to 100. Okay, so I think what we should do is we're gonna put all of this in a while loop, or not really a while loop. Let's take a look. Yeah, you know what, let's do a while loop. So the way this is going to work is the while loop will run every single time until the user guesses the correct number. So while true, and again, the true statement basically makes it run forever, and the way we'll break out of this while loop is by using the break statement. Okay, so while true, we're saying user guess is equal to input guess a number between 0 to 100. So this is our main input statement. Okay, now we want to say if user guess, and actually, you know what, we actually have to add the spaces over here. Remember the 4 indentations of Python? So user guess is equal to input if user guess is greater than com guess. Okay, so if the user guessed higher than the computer's guess, we're gonna tell him, hey, you got to print guess lower. Okay, now what if the user guessed lower than computer guess? So elif user guess less than computer guess, what then? Then we're going to say print guess higher. Okay, and last but not least, else. So if it's not higher, if it's not lower, then that means what? You got to well, it's the correct answer then, right? So if the guess is not higher than the computer guess, if it's not lower than the computer guess, then we know the user has guessed the computer guess, right? So else print, congrats, you have guessed the correct number. And then all we have to do is break out. So break. All right. So this is our very simple guessing game. So I'm going to go ahead and save this. If you are on a Mac, Command S. If you're on a Windows machine, Control S. So save as, and I'm going to save this as my guessing game Python. So go ahead and save. All right, and I'm going to go ahead and run this. So what happens? Nothing actually. That's odd. So let's go ahead and get this back. Run module. Alright, there we go. So guess a number between 0 to 100. I'm going to guess 50. Unorderable type string is greater than it. Alright, so this is our first error, something I should have known about, but I didn't, so that was my mistake. Our first error is that when we're checking if user guess is greater than com guess, remember, when we use the input statement, it'll always take in a string. It won't take in an integer, it'll always take a string. So what we have to do is we have to convert this, or actually, instead, we have to convert our input into an integer. So if you remember back 30 or so lectures ago, we were talking about the int and the str functions. The int function converts our string, which is a number, into a normal integer. The string function, on the other hand, converts any integer into a string. So by converting our input into an integer, we won't get this error anymore. So run, again, it's just F5, so let's just go ahead and hit F5. It says source must be safe, okay? Guess a number between 0 to 100, I say 50. So it says guess higher, okay? I'm going to say 75 or 76. It says guess lower, so 60 maybe. Guess a number, guess higher, so 65. Higher, 67. Higher, 70. Higher, 73. Lower, so it's between 70 and 73. 71. Yay, we guessed the correct number. Awesome. So this is a very basic guessing game we created through Python, and this is a lot of fun. So if you were able to create this guessing game by yourself, fantastic job. I mean, that's truly amazing. Otherwise, hopefully you had fun creating this very simple guessing game. Now I have a quick challenge for you, okay? Actually, even before the challenge, let's quickly talk about one thing you might fix in this guessing game. Currently, right now, let me just go ahead and run this again. So getting this back and F5. If I say 150, for example, it allows the guess. If I say negative 2000, it allows the guess. So one thing you might want to consider while creating this application is that limit the user's guesses to between 0 to 100. For example, if I guess 150, I should see a message saying, hey, you need to guess between 0 to 100. And if I guess minus 2000, then I should again see a message saying you need to guess between 0 to 100. But that's something you can work on later. Again, that was just one piece of advice I could have given. Now comes the challenge. So I always like giving out challenges to my students. I've done that in my Apple Watch course. I'm doing that in this course. And the challenge for today, or at least for this section, is that I want you to create a computer-based guessing game. And the way this will work is you will guess the number, or I'm sorry, no, wait. Yes. So you will have a number in mind, okay? You will have a number in mind, you'll store it in your memory, and then the computer will guess the number, okay? And the way this will work is, for example, the computer will initially print out, let's say 50. And then you'll either say higher or lower, and then based on that, the computer will either guess higher or lower. For example, if I guess the number 60, my initial guess of the computer was 50, I printed out higher, the computer realized, hey, I now need to search from 100 to 50. So suppose he searches 75. Then we say lower, and now the computer realizes I need to search from 50 to 75. So it continuously decreases the range it's searching through. Again, this might be a little bit over your head. I will be adding the code for this computer guessing game in the next lecture. But if you understood what I'm trying to say, definitely try it out and compare your code to mine. See you in the next lecture. Alright, so in the last lecture we talked about creating a very cool guessing game. And we did that. And I thought it was pretty fun and we definitely learned a lot. And if you were able to get that computer guessing game that I was talking about where you thought of a number and the computer guessed it, awesome. You may have verified your code with my code, and if you got the same results, fantastic. Now we're not gonna move on to a different module. Actually, we're gonna stay with random module for another lecture or two. And I want to talk about some other functions that are there with the random module. So for this, we won't need to create a new file. There'll just be simple functions. So go ahead and import random into your IDLE or into your shell. And the first function I want to talk about is called a choice function. Okay? Random.choice. And the way this works is, for example, the random.randint picked a random number out of a set of numbers from 0 to 100, 100 to 150, whatever. The random.choice picks a random object from a list. So again, concept is very cool. Let's go ahead and check it out. So I'm going to go ahead and create a list. Actually, I'm going to call this, let's say, food. And in my food array, I'm going to put in some good stuff. Ravioli, I had that yesterday. Let's go pasta, pizza, and let's do one more. Let's go ahead with cheesecake. Again, random stuff. You can do whatever you want. I believe there's an E there. Cheesecake. So now using the random.choice function, what we can do is, let's say we need to generate a random object. We didn't want to get the first object all the time, but we wanted a random item from this list every single time. How would that work? Well, we'd use the random.choice. So what we can say is print random.food. I'm sorry. Random.choice, and then in brackets food. So basically the choice parameter takes, the choice function takes in one parameter, which is the list. If we do that, we get cheesecake. Let's go ahead and do this one or two more times. Cheesecake again, and ravioli. Awesome. So the choice function can be used to generate random items from a list, which again is very useful. Now to finish off our random module, we're going to talk about one last function, and that is the shuffle function. So the random.choice gave us a random item from our list. What if you didn't want to use a random.choice and instead shuffle your whole list in the first place? So instead of getting ravioli, pasta, pizza, cheesecake, what if you got pizza, ravioli, cheesecake, pasta? And then it switched around every single time. Well, that's where our shuffle function comes in. So what we can do is, let's go ahead and just print whoops, my bad. Print shuffle.function. I'm sorry. Brain freeze, I'm sorry guys. Random.shuffle. And in parameters, we're going to put in food. Hit enter. So again, we get none, but now if we print out food, as you can see, it's been shuffled. If you do random.shuffle food again and print out food, you'll get a different set of items every single time. So again, both the random.choice and the random.shuffle are very interesting functions whenever you're creating Python scripts. One gives you a random item out of your array every single time, and the shuffle will shuffle up your array to make it a different order. So definitely cool. This is the end for our random module. And in the next lecture, I'm not sure which module we're going to be talking about, but I believe we'll talk with the sys and the os module again. So see you then. Alright, so today we're talking about the sys module. And the sys module stands for system, and it allows us to perform some system-based functions. For example, checking for the version, stuff like that. So the first function, or actually before that, let's go ahead and import sys into our module or into our shell. And once we do that, we now have all the sys functions handy. So if you want to view the different functions, what you can do is you can type in sys dot, and then using your down arrow key, you can now take a look at all the different functions there are with the sys. There's this sys.exit that exits out of the module. There's sys. Let's take a look. Sys.version. Sys.version will give you the version of your machine and so on. So we're going to be talking about three functions with the sys module today. The first one is the stdin, okay? And that's short for standard input. That's basically like the input, except with the stdin, you can specify how many characters you want to read in. So I'm going to show you quickly how this works. First thing you have to do is you have to create a variable. So I'm going to call this our input statement. And this is going to be equal to sys.stdin.readLine, okay? And all readLine says is it's a function which is used to read a line of text typed on the keyboard, okay? And once we hit enter, it's now reading whatever we type. So this sentence is going to be read by the function we just entered. Alright, so now if we print out input statement, okay, what happens? This sentence is going to be read by the function we just entered. So you're probably wondering, well, what's the difference between this and our input statement? Well, there's not much to it, I guess. I mean, both of them do the exact same function, except with the sys.stdin.readLine, what you can do is you can also specify how many characters you want to read. So let's say you were asking the guy to enter his password, okay? And you have a limit for the number of characters that can be a password. So let's say this guy entered 11 characters, and the limit for yours is 10. So instead of reading all 11, what you can do is you can just take in the first 10. Again, that's sort of pointless, but I'm just giving you an example over here. So what you can do is, let's go back to our input statement and, oh, whoops. So, can I change this? Yes, we can. Okay. So in our read line over here, go ahead and specify to be the first 10 characters. So we're only going to get part of sentence and full this, but if we just hit enter, it gives me an error, multiple statements found. Okay, that's probably because I had just done that. So I'm just going to go ahead and write this again. Input statement is equal to sys.stdin.readLine, and then in the brackets, I want to put in, let's say, the first 10 characters. So now if I just type in, this is a password, okay, and hit enter, and if I now print out input statement, what happens? We get this is a. So everything after the first 10 characters wasn't even considered. All this did is it read the first 10 characters. So again, it's pretty cool if you just want a specific amount of characters. Otherwise, stick to input. There's no need to write all this random long line stuff and also having to import the sys module. Okay? Now, the next function, and again, it's quite similar to this, is the stdout. So just like there was a standard input, there's a standard output. And all the standard output does is it's basically the same as print, it just prints out the line. Okay? So let's go ahead and talk about it. It's just going to be sys.stdout.write. Okay? And again, remember this write function, we've used it before in files. So sys.stdout.write, this statement is awesome. Okay? So this is basically just like the print. Again, This returns a number of characters as well in case you wanted that. But look, don't use system for that much. It doesn't have much of a purpose currently. Again, print and input, both of them do the exact same functions as sys. I'm just telling you some modules and some functions that you can use with them just to get your basics cleared out. Now, the last function we're going to cover for the sys module, and trust me, this is the last one, is the version. Okay, so we've imported sys, and go ahead and just call sys.version. Okay, and it gives me, hey, the version of Python I'm using is 3.4.2. It tells me the date. Trust me, it's not October 5th, 2014. I have to change that. And it gives me some 4.2.1 stuff and my Apple Inc. and stuff like that. But yeah, so this can tell me what version of Python I'm using and some other detailed information. Awesome. So let's do a quick recap of what we covered in this small lecture. We talked about 3 functions with the sys module. We learned how to read,